Welcome to the preparatory webinar for the technical working parties. My name is Leontino Taveira. I work for the Office of the Union. The objective of the webinar is to enable participants to participate more actively in the technical working party session. The content of this series of webinars has started yesterday with the first preparatory webinar and continues today with disease resistances, and also tomorrow a third webinar will be held. The program for our webinar starts with the basic requirements for characteristics in the DUS examination, and it continues on to UPOV guidance on physiological characteristics, followed by a panel discussion with UPOV members and a session on questions and answers. On this note, I would like to pass the floor on to our first speaker, Mr. Nick Hulse.
Good morning and good afternoon to everyone. I'd like to start with a little bit background on why having some basic requirements for characteristics is important. It's important to have a harmonized approach. We'll just wait for the slide to change. Yep. It's important to have a harmonized approach within UPOV members to facilitate the cooperation in DUS testing. For example, if a DUS test is conducted in one authority and the DUS report is then provided to another authority, it will be more likely to be accepted without the need for any further testing if the characteristics used are well understood and consistent with the test guidelines. Similarly, a variety description prepared in a harmonized way is internationally recognizable and clearly establishes the expression of the key characteristics of the variety. Not all characteristics are suitable for use in DUS examination. The test guidelines for the different crop types include characteristics that are considered suitable for DUS examination and the harmonizing of variety descriptions. Guidance on determining whether a characteristic is suitable for DUS testing is provided in section 4 of the General Introduction to the Examination of DUS and Development of Harmonized Descriptions, so-called the General Introduction. This guidance is useful for those involved in the drafting of new or revised test guidelines and for DUS examiners testing varieties of species where there are no established test guidelines. The General Introduction explains that some characteristics may vary widely in their expression due to environmental factors or may not be consistent between generations, while some other characteristics may not have sufficient variation within the species to establish distinctness. So, for a characteristic to be suitable for use in DUS testing, it should meet the following 6 criteria. It should result from a genotype or combination of genotypes, so it must be heritable. It must be sufficiently consistent and repeatable in a particular environment. A good characteristic is one that is not too influenced by the environment. And whilst most characteristics will be influenced to some degree, it should at least be consistent and repeatable under the same conditions. Characteristics should also exhibit sufficient variation to establish distinctness. A characteristic that has a very narrow range of expression is not very useful in separating varieties. It must also be capable of precise definition and recognition. The expression of the characteristic must be able to be clearly defined. It should also allow uniformity requirements to be fulfilled. So within a variety, the expression of the characteristic should not vary outside allowable thresholds. Similarly, stability requirements also need to be fulfilled. So when propagated, the expression of the characteristic within a variety should not change significantly. So generally speaking, what type of characteristics are acceptable? Are agronomically important characteristics such as yield or straw strength acceptable? Before I, whoop, let me go back. Before I answer that question, we need to talk about whether a variety that has value or merit can be used. And it's not a requirement of to have a characteristic which is commercially important. The general introduction at paragraph 4.2.2 clarifies there is no requirement for a characteristic to have any commercial value or merit. However, if a characteristic does have value or merit and it fulfills all the 6 criteria, then it may be used. So let's look at an example using the tomato test guideline. For those of you that attended the webinar yesterday, there was a good presentation by the Netherlands that used tomato as an example, so I will continue to use that theme. The test guideline includes leaf type of blade, which could be considered as being of little commercial value, and it also includes a characteristic fruit color, which is clearly of commercial value. Both of these characteristics fulfill the 6 requirements, basic requirements for a characteristic. So let's have a look, generally speaking, and this is not always the case, but generally speaking, fruit color and leaf shape would fit the 6 requirements and therefore be acceptable characteristics. Well, let's have a look at yield. And agronomically, yield is very important. For example, in grain crops, yield is often reported as tons per hectare or perhaps bushels per acre, and is generally the result of many factors such as seed size, seed weight, ear density, ear length, number of tillers, and so on, as well as environmental influences. Yield would generally satisfy the first requirement, as although it is influenced by the environment, it does result from the given genotype of the variety. It would be very difficult for yield as a characteristic to satisfy all of the requirements from B to F, as there are so many factors that contribute to yield. However, the components of yield, such as ear density, ear length, tiller number, seed size, or seed weight, are potentially acceptable characteristics for DUS examination, provided they can be shown to meet those 6 basic requirements. Thank you. I'd like to now hand the floor back to Leontino. Thank you.
Thank you, Nick. We continue on with this presentation on document TGP12, the guidance for physiological characteristics, which include disease resistance characteristics. You've seen the 6 criteria for a characteristic to be used in DUS examination. We would like to compare these, as it was demonstrated with yield, in relation to disease resistance. So disease resistance comes from a given genotype or combination of genotypes. Well, here you should know the genetic control. It is desirable that the experts know genetic control of the resistance. So whether it's a monogenic or polygenic disease. Also, in relation to having sufficient consistency to be repeatable in a particular environment, it is paramount that the conditions are standardized for the characteristic to be repeated, for the assessment of the characteristic to be repeatable. And this would include the source of inoculum, which should also be standardized, which may require ring tests to do so. Exhibiting sufficient variation so as to be able to distinguish between varieties, well, the experts have to define the scale of the resistance, whether it is a 1 in 9 scale, just absent or present or susceptible resistant, or in varying degrees of resistance, such as for quantitative characteristics. Is disease resistance a disease resistance characteristic capable of precise definition and recognition? Here, it's very important to precise and define the race or strain for the organism against which the varieties are being tested, because it varies across varieties and across to the different pathotypes or strains of a particular disease. Does it allow uniformity to be assessed? Here, the method should allow for the assessment of individual plants as to allowing uniformity to be assessed. There's a variation, there's a range of variation of symptoms across the plants in a disease resistance trial, which should not be interpreted as lack of uniformity, as this is an effect of the inoculation and the other variables in such trials. Does it allow for the stability requirements to be assessed? Here, the same as for other types of characteristics, disease resistance characteristics should also enable assessing stability. So in overall, it's just a particular type of characteristic, a bit more difficult to be assessed and certainly more expensive too. You will see in UPOV test guidelines, as it will be discussed during the technical working party for vegetable crops next week, that such special characteristics are very well described. In particular, the method for performing the assessment is thoroughly discussed with several items, compulsory items that should be taken into consideration, from mentioning or precising the pathogen all the way over to the interpretation of results. Not only disease resistances are described in UPOV guidance, other special characteristics such as chemical responses induced by external chemical agents, such as, for example, a herbicide. Such characteristics are also used in test guidelines and should equally be well described and standardized. Another type of special characteristic also prescribed in UPOV guidance is the use of protein electrophoresis. By itself, this type of characteristic may not be sufficient to establish distinctness. It is very important to know the genetic control and standardize the method for scoring this type of characteristics. If you'd like to see a few examples of these characteristics, please could you consider the test guidelines for maize, wheat, and barley. Other types of special characteristics could be, for example, the assessment of chemical compounds in varieties, which require bulk sampling, where many plants are gathered and homogenized for assessing, for example, a particular chemical component. Not only they need to fulfill the basic criteria we have just now explained, but there should also be sufficient genetic knowledge of the genetic control of the characteristic and an initial assessment of uniformity of individual plants performed, along with information on how the characteristic changes from plant to plant and a full description of the method. And if you'd like to learn more about this type of characteristics, please could you consult document TGP8, trial design and techniques used in DUS examination. On this note, I would like to complete the first part of our webinar and start the panel discussion where UPOV members will present their experiences in using such special characteristics like disease resistances. We would like to start by inviting Ms. Christelle Jouy from France to take the floor. Please, Christelle, the floor is yours.
Thank you, Leontino. Good morning, good afternoon, everybody. I'm very pleased to have the opportunity to share with you some information. So I prepare a small PowerPoint.
Christelle, I guess you're on mute.
Sorry. I said good morning, good afternoon, everybody. I'm pleased to have the opportunity to exchange with you. A disease resistance characteristic. What type of characteristic is it? First, it's a pair of two living organisms which interact together, also with between them, but also with the environment. We have a bioaggressor and the species. It's a phenotypical characteristic regarding the observed symptoms, and it is assessed thanks to a standardized biotest based on a published protocol. It can also be assessed by molecular markers. I mentioned the three couples which were validated in the UPOV guideline, but most of the time, really the majority of the times, we are performing biotest in lab conditions. A disease resistance characteristic can be a qualitative characteristic with an answer yes or no, susceptible, resistant, or a quantitative one. And in these circumstances, we have a panel of level of expression, but most of the time we are working with only 3 levels of expression: susceptible, intermediate resistant, and highly resistant. Once again, this last point is under discussion, and perhaps next week we will have the opportunity to go a little bit deeper on this subject. So, as mentioned previously by Leontino, this type of characteristic can be with or without an asterisk, which is important for an international standardization between the different partners. This type of characteristic can also be or not a grouping characteristic, and especially in disease resistance in vegetable species can be very interesting to optimize the management of a reference collection and to allow us, examination offices, to select the more relevant example varieties.
I guess it went mute again.
Yep, I think you mustn't touch the keyboard.
Okay. Probably it's yes, the problem. Okay, so in the chapter 7 of the guideline, we have a list of characteristics. We can identify there some strategic point. The little plus in the left side allow us to know that you will benefit of additional explanation, and we will have some detail a little bit later. We can also identify the example varieties, which are most of the time commercial varieties, which can be easily identified or easily provided. And you can see also there the level of expression. Regarding another strategic chapter of the guideline, it's in chapter 8, and more precisely the addendums of each disease resistance test with a proposed protocol. And this disease protocol is linked to a specified characteristic. It follows a UPOV format described in the TGP 12. Clearly, in this protocol, you have a standardized chapter allowing us to follow the same rule to describe this kind of activity. As you can see here, we can mention very briefly the source of the information. And in the case of resistance to Tobamo virus in the paper, we can mention that the revision, the updating of this document was provided thanks to a collaboration between different examination offices. And in this case, it was based on the result of a European project managed by CPVO. Once again, I come back on the standard disease resistance protocol. And as mentioned in red, here in this presentation, but in bold in the paper document. It's strategic chapter, which are compulsory to build this protocol. Once again, it's a guidance, not a strict prescription, but it's highly advised to follow it, and more particularly the red chapter, to allow to work together. Other elements can be used, but depending on the resistance test protocol. This compulsory chapter are the identification of the pathogen, the host species, the source of inoculum, the isolate. Once again, it was mentioned previously by Leontino. We have to know precisely which type of pathogen we have to manage with, we have to work with. The number of plants to consider, the number of replicate, the controlled varieties, which is not necessarily the same as example varieties, because here we need to be really confident on the results provided by controls. The stage of inoculation, the inoculation method, the methods to observe the results, the observation scale, the validation of the test, and then the interpretation of data in terms of the UPOV characteristic states. 1-9 for a qualitative characteristic, 1-3 for a quantitative one. Now I will illustrate these topics with the way we are working with in France. This characteristic allows us to describe varieties, and we are following the UPOV protocols. We are also, as any other examination offices, we could be in the position to propose partial revision to introduce improvement or updatings of these protocols. And more than only the description of the characteristic, it's also very useful for us as a tool to structurate the reference collection. In France, we have a more deeper structuration of a different type of disease resistances. We have identified 5 classes which have a more or less impact on the DUS exam. The first one, and which is the strategic one, it's named class 1. It's checked officially by our lab condition, and whatever the applicant declaration, it could be susceptible, intermediate resistant, or resistant. All declaration are officially checked, and it's most of the time used as grouping characteristics, which has a very interesting value to allow us to manage the reference collection. In class 2, we are in charge of an official check of all the declared resistant only. In the third class, we are in the situation to collaborate with the applicant to perform blind test, and we can validate the result of this test. And the last class, the fourth class, it's only for information. As you can read in this table, we are working on 56 pairs of pathogen species in class 1. So we have there 56 grouping characteristics. In class 2, only 33. In class 3, only 39. And in class 4, which is only a declaration, 60 pairs. Regarding the species we are working with, it's 18 vegetable species. I will not read them all, but you have them mentioned in this slide. And we are considering more than 120 pathogens. Once again, the more strategic point is the use of the characteristics, which can be used as grouping 1. Okay, I'm working very well. So I took an example with a very big vegetable species, the tomato one. And typically in the left side of this slide in blue, we can see the management of a reference collection using only morphological grouping characteristic. This slide was prepared some years ago. And at that time, the tomato reference correction was a little bit higher than 5,000 varieties. And using the morphological characteristic, regarding an example, a precise case of an application, we can reduce the number of example variety to introduce in the trial to a little bit more than 100 variety. Clearly, it's too much. We cannot manage so huge trial, and introducing disease grouping characteristic step by step. If you would like to have a look more precisely, variety characteristic by characteristics, we can divide the number of variety to include by 10. We were in more than 100, and we are now with at least, sorry, I can see, oh, sorry, I click on the table, it was a mistake. Okay. Okay. And again, the use of disease resistance characteristic allow us to strongly diminish the number of variety to include in the disease resistance trial. I would like also to underline that we are also deeply involved in R&D projects to share, of course, but also to improve our knowledges around disease resistance characteristic. In the framework of EU level, thanks to CPVO co-finance project, it was the case of Armorez project 1, 3, and 4 for the harmonization of the test protocol. The last one and the running one is more Armorez call, and we will have the opportunity to present it next week. It's a voluntary involvement of the examination offices, but also the involvement of some breeding companies. We have also French reports, a French project co-financed by the French Ministry of Agriculture, and a national initiative performed by JVS. It can be on a wide panel of activities, and one of the last one, which was for us also strategic, it's the use of statistics to assist the pathologist to interpret the results, the quantitative results in the case of quantitative disease resistances. Sorry. And it was the last slide. Thanks a lot for your attention. And I will be pleased to answer to your question in some minutes. Thanks a lot.
Thank you, Christelle. Now we continue on to our next panelist, Mr. Yoshiyuki Ono from Japan. Please, Mr. Ono, you have the floor.
Okay, thank you very much. I would like to explain this disease resistance and physiological characteristic in DUS examination Japan. So today I would like to make a short presentation, and we have here we have the contents of example of disease resistance and physiological characteristics, and second one is a current issue to be resolved. So I would like to introduce preliminary information on the disease resistance examination, Japanese case. So Japanese disease resistance examination is conducted by NCSS. However, conducting the disease resistance test is limited to cases when there was no distinctness between the varieties in morphological characteristic case. So this slide shows a fusarium test for the tomato variety in glass house. So here we have a level of symptom of tomato variety. There are 5 assessment scale, 0, healthy, to 4, plant died. And also we have a symptom of cross section of the stem. Here we have a table for the assessment. This table constructed by a calculation of disease index, which are sigma symptom assessment scale multiplied number of the plants divided by a total number of plants multiplied to 4. So please look at the bottom table, which is assessment node, assessment table. This characteristic is QL characteristic with absent or present. So we calculated disease resistance index, so which will be allocated this assessment table, which note 1 absent is more than 5.5 disease index, and note 9 present is less than 5.4 disease index. So I would like to explain the current issue to be resolved. So as I mentioned before, Japanese examination of disease resistance examination is conducted by NCSS. However, conducting the disease resistance test is limited to cases, only limited to cases, when there was no distinctness in morphological characteristic case. So this operational measure has advantages and disadvantages. So advantage are prompt examination and prompt grant breeders right, and also possible to physiological characteristic test for the distinctness as necessary basis. So I would like to explain the disadvantages. So we were faced disadvantages produced by a description including blank characteristic. So difficulties of exercising breeder's right by a variety description including blank characteristic. And also the NCSS do not have sufficient budget to perform the testing physiological characteristic. So to resolve this disadvantage current issue, so all amendments of Plant Variety Protection and Seed Act had to enforce from April 1st, 2022, this year. So first one, our new system is applicant have to pay the payment for the examination fees. This examination fees, all examination fees are prescribed in Ordinance for Plant Variety Protection and Seed Act in Japan. And the next one is categorized mandatory characteristic and optional characteristic for the examination. Third one is optional characteristic, mainly physiological characteristic, will be conducted to test by applicant declaration. All amendments of Plant Variety Protection and Seed Act had to enforce from April this year. So we recognize the advantages is prompt examination and prompt grant breeders' right by a declaration of optional characteristics for disease resistance and physiological characteristics, etc., from the applicant. And next one is examination fees go to directly NCSS as an independent revenue sources. And third one is international cooperation for the exchange DUS report to be promoted. So we recognize no disadvantages from this April. My short presentation is finished. Thank you very much for your attention.
Thank you, Mr. Ono. Now we would like to pass the floor on to our next panelist, Ms. Gosje Blokker from the Netherlands. Please, Gosje, you have the floor and the mouse.
Yeah, thank you very much for giving me power to use the mouse. Good morning, good afternoon. This is Gosje Blokker calling from the Netherlands. I'm working at the Naktaanbouw. This is the office for the examination office for DUS test in the Netherlands for 17 years, responsible for DUS tests of watermelon, melon, gherkins, carrots. And I was asked to tell you something about the resistance, disease resistance test in DUS testing in the Netherlands. So I will tell you something what we do. Oh, sorry. Yeah, why? Oh, Jesus, yes. Okay, the power is too big, I see. Why? When do we test varieties for diseases? We use the results of resistance tests and in DUS tests for listing for marketing and also for plant breeders' rights. We have at the Naktaanbouw team who is responsible for testing the diseases, and this team is continue busy with the tests, and 90% of the tests performed are for the application for listing and plant breeders' rights. These teams also perform resistance tests for inspection, and 10% of the work is some service. So, in seed companies have a question about the results of a disease test, they can ask us, and we perform the test. Next, why do we test resistance diseases? In some cases, the diseases characteristics are part mandatory, obligatory of the in the DUS test. We would like also to know in our case, we have a lot of application, about 800 vegetable application per year. In some big crops such as tomato, pepper, or lettuce, it helps us when we know the resistances against certain diseases and pests. We can group the varieties and regarding the resistances, and in this way to limit the amount of similar varieties. I will tell you later as an example. And in some cases, it happens from time to time that the difference in resistance against certain disease. This is the only one characteristic where is the difference between the varieties. Efficiency. about in the DUS test. I will show some small example. For example, here you have the melon variety type Piel de Sapo, and this candidate variety is resistant, is given by the applicant to be resistant against two races of Fusarium, to MNSV virus, and Apis gossypi. We have to look for the similar variety in the test to be with which we would like to compare in the trial. In our database, we found 160 varieties, which of the same type. And when you go further, you will see that we have 107 varieties which are resistant to both races of Fusarium, then 75 resistant to both races of Fusarium and MNSV, and only 35 varieties which are resistant to all races, two races of Fusarium, MNSV, and Apis gossypi. You see that the information we have about the resistances from the TQ, technical questionnaire, you can limit the amount of varieties you have to have in your trial from, this is just an example, from 160 till 35. This is only using the information about the resistances to diseases and pests. If you have 35 varieties, you can go further with morphological characteristics, and then you you limit this way the amount of similar varieties. It helps us to make the trials possible, because we are also limited by the space in the greenhouses of in the open field, and using only the using the characteristic resistance characteristic, you can make your trial more efficient. I will show you further what kind of diseases we test at our place, and you can see that tomato we test tomato for this diseases: spinach, lettuce, pepper, melon, cabbage, and cucumber, pea, and beans. And you see that the amount of tests we perform per year is increasing every year. These are the old data, but it gives some idea about amounts of tests we perform at our places. Is about 5,000 per year, while half of these tests is this for lettuce. You can imagine we get every year about 150 new applications of lettuce. It would be impossible to have all those varieties and similar varieties in the database. We have maybe 5,000 potentially good similar varieties for lettuce. So using the information about diseases and to be able to perform the disease test, we can limit the amount of similar varieties. So this is the important issue and purpose. We perform at NACTAB so many diseases tests to be able to limit the amount of similar varieties and to make the DUS test efficient, and also to try to make it cheaper. I can understand that to be able to have such amount of tests, you have to invest in the lab, in the people who has the knowledge to perform the test. This is what said everything, what said Leontino in his presentation. It costs money, but you also have the benefits from it. So in some cases, if you have so many applications, it is maybe worth to establish such facilities to be able to perform the disease resistance. This was my story. Thank you very much for your attention, and see you next time at the discussion. Thank you.
Thank you, Gosia. We would like to start with Ms. Stefania Palma from Brazil. Please, Stefania, you have.
Let me see. Well, good morning. I am Stefania from Brazil. I am coordinator of the PVP office since February. And thank you for the invitation. It's a pleasure to share our experience. Let me see if it's working. Yes. I brought it to this webinar, the soybean case, because soybean is 1/3 of our applications. The most part of the US tests of soybean are conducted in Brazil. Our test guideline has only 37 descriptors. 8 of these descriptors are disease characteristics that are mandatory to be informed. 7 of these characteristics are disease characteristics that are optional to be informed. And we have also 1 characteristic that is reaction to peroxidase. We have difficult to distinct varieties of soybean, and the disease characteristics are very important to help us in the distinctness. This is a picture of our test guideline, just to show that for these are the mandatory characteristics, disease characteristics, and just to show that we have 3 states of expression: resistant, moderately resistant, and susceptible, with the notes 1, 2, 3. Is the same for the optional disease characteristics. In Brazil, the DUS test is based on breeders' testing, and for disease and physiological characteristics, it's required additional care and strict driving criteria and appropriate method of assessment, and protocols recognized and widely adopted. So we have 2 peroxidase assessment protocol available in our Ministry of Agriculture website, and this characteristic sometimes is retested in our laboratory. And for disease characteristics, we have the protocols available at SNPC webpage, and the trials are conducted by the breeders, but sometimes they don't have a structure, and they can choose for contracting a third laboratory to do the test. This is just to show how is the disease protocol for each characteristic. It has the description of the methodology and a bibliographic reference, and also pictures to illustrate the symptoms, and also the states of expression according to the symptoms. Sometimes breeders inform a new disease characteristics, and they have to inform the protocol, the method of examination, if they have photos, and send us a specific report about the assessment of the characteristic, and depending on the case, we will consider or not in the distinctness of the variety. Well, how our system is based on breeder testing. We receive the table of characteristics with the description of the variety, and put this information in the Gaia system, and the Gaia does the job to find the similar varieties. I don't know if you can see very well, but in this example, in the red, square. Both characteristics, or both varieties inform the all states of expression of all disease varieties, but sometimes we they don't inform the optional characteristics, and it's difficult to us to distinct varieties if they don't inform all the disease characteristics. So sometimes we ask them for more information or for more tests. Well, we consider a variety distinct of another when one is resistant and the other susceptible. But in some cases, the only difference between two varieties is one disease characteristic. And in that case, we use to send the variety to a new test. And when the states of expression are next, like resistant and moderately resistant, or moderately resistant and susceptible, we don't consider distinct. So we ask for more information or send the variety to a test. Usually the tests are blind tests side by side. The samples are organized and codified by our laboratory, and we send the samples to the breeder, and he is responsible to conduct the test or contract a third laboratory to do that. And they have to send us the report with the assessment of the characteristic that we demanded, and we will analyze the report and decide about the distinctness of the variety.